Hello, in this video we're going to look at the Oaxaca decomposition method. So what is the Oaxaca decomposition? A method to analyze the wage differential between two groups, to determine the portion of the wage differential that is attributable to differences in skill and the portion that is potentially attributable to discrimination. There are some problems with this method. It may overstate the impact of discrimination if important variables that affect skill and productivity are not controlled for. The method will also not pick up pre-market discrimination, such as schools perhaps restricting access to certain fields of study to only men. Using data only on wages may overstate the wage differential in favor of men if women prefer more of their compensation in the form of fringe benefits. So just some caveats and things you need to be aware of when employing this method. So what we're going to do, we're going to estimate two regression equations where W is the wage and the subscript M represents males. The subscript F down here represents females. And we're going to keep things simple at first. The independent variable here is going to be years of schooling, S. And so first thing we're going to do is we're going to evaluate these equations at the mean values of the independent variables. So mean years of schooling of males will be given by this expression. The mean years of schooling for females will be given by this expression. And as a result, by evaluating the regression at its mean values, we'll get the mean value of wages for males will equal this, and the mean value of wages for females will look something like this. So just rewriting that. So given these two estimated regressions, the differences in coefficients represent potential discrimination. So the coefficient here, the vertical intercept, the constant term here for males, minus the constant term or intercept term here for females, that difference will partly reflect potential discrimination. And then another source of potential discrimination might be the fact that males are getting paid more for each year of schooling than females, and that'll be picked up by this second term. So if the coefficient on males is exceeding the coefficient on females for each year of schooling, then that is an indication of potential discrimination. Differences in productivity variables represent differences in wages due to skill. So part of this earnings differential between females and males may simply be due to the fact that males on average have more years of schooling than females, and that's going to be picked up in this second part here. We can extend this analysis to regression equations with more than one independent variable. I'll do it with two independent variables here. So our second independent variable is going to be X, which could be years of work experience. So in this framework, differences in coefficients represent potential discrimination. So we got three things here. The difference in intercept terms, part of that is maybe representative of discrimination. The fact that males may get paid more than females for each year of schooling, also part of the discrimination equation down here. And the other thing here is that males may get paid more for each additional year of work experience compared to females. In terms of differences in productivity variables, males could be simply being paid more because on average they have more years of schooling, and on average they have more years of work experience. All right, let's do a numerical example. So here is an estimated regression equation for males. The wages of males, maybe weekly earnings here, equals 350 plus 10 times S, which is years of schooling. And for females, we get this equation. Let's assume in the data that the average years of schooling for males is 15 and the average years of schooling for females is 10. So evaluating our regression equations at these mean values, we get the mean wage for males of $500, the mean wage of females of $400. Therefore, the raw wage differential is $100. And so what we want to do here is how much of this $100 represents just differences in skill, the fact that males on average have more years of schooling. How much of this is due to potential discrimination. So let's look at the potential discrimination part first. Differences in coefficients represent potential discrimination. So looking at the differences in the intercept term, 350 minus 320, that's part of it. And then we'll look at the differences in the coefficient on years of schooling, so 10 minus 8 times 10. And if we do the math here, we get $50. So half of this raw wage differential is attributable to potential discrimination. Therefore, the other half should be due to differences in skill, and we can see that down here. Males on average have 5 more years of schooling than females. If we multiply that by the coefficient on males in the males' earnings regression, we get $50. So to sum up, we found a raw wage differential of $100. Males were earning $500, females $400 a week. Differences due to discrimination, we found that to be $50. So 50% of this raw wage differential represents potential discrimination. And in terms of differences due to skill, half of this $100 represents simply the fact that males on average have more years of schooling than females. All right, I hope you found this video helpful.